Let's solve rational equations. So we're going to start with a very simple example. Suppose we have 2 over 2x minus 5 equals 6 over 2x minus 3. And the first thing that we want to find is our LCD, which we do by ignoring the equal sign and just saying what is it that goes into both. And then we're going to say, what can x not equal? Well, x can't equal 5 halves, and x can't equal 3 halves. And we need to make sure we come back and check our answers against that later. Then we need to multiply both sides by the LCD. And we'll notice that that means that part of it's going to divide out. And so we're left with the 2 on top times the 2x minus 3 we're missing equals 6 times the 2x minus 5 that the right side is missing. We then distribute and get 4x minus 6 equals 12x minus 30. Let's minus 4x from both sides and add 30. And we get 24 equals 8x. Divide by 8. And we get x equals 3. Now we need to check, and the first thing we're going to check is we make sure that 3 is not 5 halves and 3 halves, and it's neither. Then we're going to plug it in and see if 2 over 2 times 3 minus 5 is the same as 6 over 2 times 3 minus 3. Well, this is 6 minus 5, so this is 2 over 1. And 6 minus 6 is 3, and so we get 6 over 3, and 6 over 3 reduces to 2 over 1. I get the same thing on both sides, so my answer checks out, and I'm able to move on. To look at a different example, suppose we have 2 over x minus 1 over 6 equals 5 over 2x minus 1 over 3. So now we're going to look at our 4 denominators. We're going to look at the numbers first and get a 6 and an x. So we're going to multiply everything by 6x. And we're going to reduce any fractions that we can. So the x and the x leaves a 12 minus the 6 and the 6 leaves just an x equals the 2 and the 6 leaves a 3, and the x's are gone, so this is a 15. And the 6 and the 3 cancels and leaves a 2, which is plus 2x. Or not plus 2x, it's minus 2x. Always make sure you're checking those signs. We add 2x to both sides. We subtract 12, and we get x equals 3. We got it again, and we go back and we make sure x cannot equal 0. That's fine. 3 isn't 0, so that still works. So we get 2 over 3 minus 1 over 6 equals 5 over 6 minus 1 over 3. So this becomes 4 6 minus 1 6 equals 5 6 minus 2 6. We end up with 3 6 on both sides. And sure enough, that's the same. So again, x equals 3. And that's just because of this problem. We won't always see x equals 3. One final, more complicated example. Suppose I have the following. 3 over p squared minus 4p plus 3 plus 6 over p squared minus 2p minus 3 equals 5 over p squared minus 1. So the first thing we need to do is find our LCD, which is going to require factoring. Minus 3, minus 1, p minus 3, p plus 1, p plus 1, p minus 1. And so our LCD is p minus 1, p plus 1, p minus 3. Let's write that, p minus 3 again. And p cannot equal minus 1, minus 3, or 1. So now we're just going to multiply everything by the LCD, and we just get what it's missing. So this is p plus 1 times 3 plus p minus 1 times 6 equals 5 times p minus 3. And we now distribute 3p plus 3 plus 6p minus 6 equals 5p minus 15. Combine like terms. Solve for p. So we'll subtract 5p and add 3. And we get 4p equals minus 12. So we divide both sides by 4, get p equals minus 3. But, and that's a positive 3. Make sure we get this right. We check. This doesn't conflict with that because they're opposite signs. So I made a mistake earlier up here. It's supposed to be a positive 3 because that would make that 0. And since minus 3 works, we can plug it in and get 3 over minus 3 squared minus 4 times minus 3 plus 3 plus 6 over minus 3 squared minus 2 times minus 3 minus 3 equals 5 over minus 3 squared minus 1. This is 9 plus 12 plus 3, which is 24. So 3 over 24 plus 9 plus 6 minus 3 is 6 over 12 equals 5 over 3 squared is 9 minus 1 is 8. 3 over 24 is 1 over 8. 6 over 12 is 1 over 2. Or better yet, 4 over 8. And sure enough, that equals 5 over 8. And so we have, in fact, found our answer.